The free kick is assigned against your team at a straight distance of 27.2 meters from the line of your team's goal. The ball is kicked with an angle of launch of 28.0 degrees, goes over your team's barrier, and, luckily for your team, hits the lower edge of the crossbar. How fast was the ball just after being kicked? First thing off, let's make a sketch. This is the launch point on the playing field. This is the trajectory of the ball. And let's say here is the crossbar where it hits. The horizontal position of the crossbar is 27.2 meters from the launch point. The vertical coordinate of the crossbar instead is the standard height of a soccer goal, which is 2.44 meters. Besides these two distances, we know the initial angle of velocity. Now we want to find the magnitude. Let's write the equation of motion for a projectile: x of t and y of t. If we set the origin at the launch point, then at the time it hits the crossbar, the ball will have an x-coordinate little d and a y-coordinate little h. Here we call t sub d the time at which the x-coordinate is equal to d. What we can do now is solve for the time using the first equation. So we write t sub d as d over v0 cosine theta 0 and substitute that in the second equation for little h. In the next minute, we're going to just do algebra to solve for v0. Let's quickly do a dimensions check before we plug in the numbers. Square root of meters per second squared divided by meters times meters divided by dimensionless quantity. That's equal to square root of 1 over second squared times meters, that is meters per second. So that's a check. Plugging in the values, you should get 19.7 meters per second.